Okay, so, here are the endpoints. So let's suppose the endpoints are, I'm trying to make the endpoints not be in fractions, or the endpoints be in numbers that won't give you fractions. So let's say we had the endpoints were 4, -2, and let's say 6, 4. Let's do this. Okay, so these are the endpoints of a circle, and you want to find the equation of the circle in standard form. All right. Now, you did other problems with this from 2.8 dealing with circles. There were 2 worksheets dealing with circles, but they did involve this kind. But you have enough information where you can actually do this. You can do this knowing what you already know. Okay, so first of all, you need to determine, or you need to remember, what is standard form of a circle? What's the equation for the standard form of a circle? Plus y minus k squared equal r squared, right? Okay. And so in order to write the equation of a circle in standard form, what must you know? You must know what? No, not the origin. The center. You must know the center and the radius. That's what you must know. What's the center here that I'm pointing to? What letters represent the center? HK. And what letter represents the radius? R. Okay. So, in this problem, do I know any of those? No, you don't. You don't know any of those. All right. Now, before you guess as to what you do here, let's look at what the circle looks like. All right. So these are my endpoints, right? Okay. So one of my endpoints is 4, -2. So 4, -2 is right here. And the other endpoint is 6, 4. So 6, 4, let's say is here. Okay? And so if I draw this segment right here, if I draw this segment, and I draw the circle, and I'm doing the best I can with this circle. Let's say this is it right here. Okay, it could be a little bit better. Okay, so notice this is the end point right here. This is the end point 4, -2. And this is the end point 6, 4. Okay, so that's the circle. That's what it looks like. That segment I've drawn from both endpoints, do you remember what that's called from high school geometry? What's that segment called from one endpoint to the other? Huh? I'm sorry, say it again? The diameter. All right, and so the diameter goes through the center. So the center is somewhere around here. All right, so the diameter goes through the center. Okay, now, how do you think you would find that center? The midpoint formula. Okay, very good. All right, so not only did you have to know the equation of a circle, but you have to know the midpoint formula, because the midpoint is the center, right? So this center, wherever that center is, whatever it is, I'm approximated to be here, whatever that center is, it's the midpoint. This center is the midpoint of the diameter. Okay, so what's the midpoint formula? Do you remember? Comma. All right, so finding the center of the circle should be the easiest of what you got to do with this problem. So finding the center of the circle is the easiest which you have to do with this problem. So the work you would do, so on the worksheet where it says show the work, all right, so this is what you would do. Now, you don't have to draw this circle. In fact, you wouldn't be given a grid for this. So basically you're going to say, I need to find the center. All right, and the center, remember the formula for center is x1 plus x2 over 2, comma, y1 plus y2 over 2. And then remember, it's a good idea to label these x1, y1, x2, y2. All right, so let's find this. Let's find the center. Okay, so what's x1? So I'm going to add x2, which is what? Over 2, comma, y1 plus 4 over 2. And so this is 4 plus 6, which is 10 over 2, which is 5, comma. Not negative 2. 2 over 2, which is 1. So that's the center of the circle, right? So that's the center of the circle. And so if you look at what I drew, it's I kind of estimated in the right place. See in this about 5, 1 right here? So 5, 1. So that's the center of the circle. Okay, so that's what you have to show. You have to show the work for finding the center. So the first thing you have to do is find the center. All right, now, so I know, so this right here is h and this is k, correct? All right. Now, what is it? What else do I need to find?
Radius.
The radius.
Distance formula?
You're going to use the distance formula. Very good. Now, there are a couple ways you can do this. So to find the radius, you have to use the distance formula. Okay, so you can use the distance formula. Do you remember the distance formula?
D equals square root of x minus x1.
Right, you subtract the x-coordinates and do what to those? Squared. So remember, the distance formula comes from Pythagorean's theorem. So that's why you remember on Pythagorean's theorem in a right triangle, you square the legs. So that's where the squaring comes from. So plus, and then you subtract the y-coordinates, right? And I square those. And then I take the square root. Okay? All right, now, you can use the distance formula in this. So in other words, what you're doing is you're finding the distance of this, and what's the segment called? The diameter. All right? So you're going to find the distance of the diameter, or find the length of the diameter. All right. So basically, you're doing these in terms of the diameter. So you found the midpoint of the diameter. The midpoint of the diameter is the center of the what? Circle. And then for the diameter, you're also going to find the length. Now, be careful. The length we find here, that's not the radius. You got to remember something from high school geometry about the radius and the diameter. Okay. So let's find the length of the diameter. So the length of the diameter, again, it's already labeled x1, y1, x2, y2. Just plug these numbers back in. You get d equals the square root of, okay, what's x2? 6 subtract x1, which is 4. And what do I do to that? Squared. Plus y2, which is 4. Subtract y1, which is negative 2 squared, correct? What's 6 subtract 4? No, it's not negative 2. Now you could have said x1 minus x2 first, and yes, that would have been negative 2, but you would have had to do what to that negative 2? Square it, and you all would have gotten what? Positive 4. Okay, so remember, these should always, when you square them, they all better be what kind of number? Positive. So that's 4, because 2 squared is 4. Now, what's 4 subtract a negative 2? Positive 6. And what's positive 6 squared? 36. And so that's going to be the square root of 40, right? You all agree? Okay. Now, leave it the square root of 40. Don't simplify this. Leave it like that for right now. All right. So I found the length of this to be, this right here, this length to be the square root of 40, right? Is that the radius? No, that's the diameter, right? What do you remember is the relationship between the radius and the diameter? The radius is half the diameter. So if this is the diameter, then this right here is the what? The radius. So from the center to the circle is the radius. So there's an infinite number of radii. and there's an infinite number of diameters. All right. So y'all do agree that there's an infinite number of diameters, right? Okay. As long as you have a segment that goes to the center and the endpoints in the circle, that's the diameter. But all these diameters should have the same length. In this case, what's the length of this diameter? Square root of 40? All right. And so we know this relationship. We know that the radius is 1/2 of the diameter, correct? So we just found the diameter. What's the diameter? Square root of 40. And so I get 1/2 times square root of 40, which can be written as a square root of 40 over 2. You agree with that? So that's the radius. So the radius is square root of 40 over 2. Do not make a mistake and say that's the square root of 20. Don't say 2 into 40, because that's not 40. That is what? The square root of 40. The square root of 40 and 40 are not the same thing. The square root of 40 is irrational. 40 is rational. Okay? Now, so in this case, it is fine to leave it as the square root of 40 without simplifying it. Because all you're interested in now this is all the work, but all you're interested in now is what's the equation of the circle. So let's plug things back in. All right, so let's do this. So we get, remember, x minus h squared plus y minus k squared equals r squared. So it's x minus h, what's h? 5 squared plus y minus k, what's k? 1 squared equal, and I'm going to put this in parentheses for right now, what's the radius? Square root of 40 over 2. What do I do to that? Square it. Okay, now listen carefully. This is not the answer you give, because you don't want your answer as a radius squared. Some of you did that on My Math Lab when you took that quiz. Some of you said 5 squared. That's not what they wanted. They didn't want 5 squared. They wanted what? 25. Okay, so you got to go further with this. All right, so let's go further with it. So the answer is going to be this. We're going to do the work here. You see this right here? The square root of 40 over 2 squared. What does that mean, the square root of 40 over 2 squared? Times itself. So square root of 40 over 2 times the square root of 40 over 2, right? What's the square root of 40 times the square root of 40 without using a calculator? What do you think that is? No, it's not square root of 80 now. It's just 40. 40 times 40 is what? 1,600. Right? And what's the square root of 1,600 in your calculator? It's 40. So that's just 40. So the thing that you learned last semester and the semester before that was that if you have the square root of 7 times the square root of 7, that's just what? 7. If you have the square root of 2.6 times the square root of 2.6, that's just what? 2.6. So the square root of 40 times the square root of 40 is just what? 40. Now, if you didn't know that, if you didn't remember that from last semester, then use your calculator. Square root of 7 times square root of 7 is the square root of 49, correct? And you didn't even have to write the square root of 49. You have access to a calculator. On your calculator, you say the square root of 7, just like this. So you'd say the square root of 7. Let me see, square root right here. Don't forget to close the parentheses, though. Times the square root of 7 again. And what do you get? 7. Okay? So the square root of 2.6 times the square root of 2.6 in your calculator gives you 2.6. The square root of 40 times the square root of 40 gives you what? 40. So that's just 40 right here in the numerator. What was the denominator? Nope. 4. Y'all would have been so crying because you wanted that extra point. What is 40 divided by 4? 10. So what's the answer going to be? It'll be x minus 5 squared plus y minus 1 squared equal what? 10. That's the answer. Okay. Again, don't leave it like this. You're not going to be happy. You gotta rewrite it like this.
So what if you use the distance formula between the center and the end?
Okay, so that's another way of doing it. Now, it is preferable. You see how everything was based in terms of the diameter? So to find the center, I use the diameter. To find the radius, I use the what? Diameter. And I use the fact that the radius is half of the diameter. Now, her question is this. What if you use the center? So instead of finding the length of the diameter, you find the length of the what? The radius. Going from the center to an endpoint, right? Okay? So it will give you the same answer. So watch. But most students will just stick with the diameter and take half of it. So this is what you would end up with. So you see where she's coming from? She wants to know, well, what if I use the center and the endpoint? Is that the radius? Sure. So if you could use this endpoint or you could use this endpoint. Y'all agree with that? Okay, I'm just going to use one of them. Let's just use the 6, 4. So let's find the radius using the center and one endpoint. All right, you get the same answer, but stick, and it's up to you what you use, but you may want to just stick with everything in terms of the diameter. So the center is 5, 1, the endpoint is 6, 4. So I'm going to use the distance formula, correct? So the distance is the square root of, you subtract your x coordinates, square them, plus subtract the y coordinates, square them, and then take the square root of that when you add them up. So this is your x1, y1, x2, y2. All right, now notice what happens when you do this one. You're going to get d equals the square root of x2. What's x2? 6. Subtract x1, which is 5. What do I do to that? Squared. Plus y2, which is 4. Subtract 1 and then square. So 6 minus 1 is, 6 minus 5 is 1. 1 squared is 1. Plus 4 minus 1 is 3. 3 squared is 9. And you get the square root of what? 10. Okay? All right, so now let's write the equation of the circle. You see the square root of 10, the radicand's 10. That should look familiar. All right, now write the equation of the circle. Okay, so x minus h. Now remember, h and k come from the center. What is this point right here? Yeah, but the center, right? Okay, so what's h here? 5 squared plus y minus k. What's k? 1 squared equal. Okay, and then I got to square. Well, I'm just going to put this right now. So r is what? Square root of 10. But what do I need to do that? Square it. Now simplify this. Don't leave it like this. So the answer is going to be x minus 5 squared plus y minus 1 squared equal. Now what's the square root of 10 times itself? 10. So it doesn't matter which approach you use. So notice. Say it again.
No, I just figured it out. You're not going to put the 2 underneath.
No, because I am actually, see this time, yeah, so this time I am finding the length of the radius. Whereas before I was finding the length of the diameter, which was, the radius would be half of that. Right, so it's up to you which one you use. The problem though is that you could have easily made a mistake with the center. So you may want to, so you may have gotten the diameter, you may get the diameter correct, but the center may be wrong. So you just got to be careful how you do this stuff.
Is this gonna be on? You say this gonna be?
It's on the final.
Okay. And you putting a video?
Not yet. I'm gonna do it this weekend.
That's cool. Thank you.
So I'm gonna give you 2 more problems with this on the video. Now I just want to the problem that we chose here, the center, the x and y coordinates were both positive, right?
Right.
Okay. Some of you on your quiz, you kind of mess up in terms of finding the center. Remember, it's x minus h and y minus k. So so just real quick, suppose that we did all this work and we found the center to be, let's say, -2, 6, and the radius is the square root of, let's say, 20. So we did all this work. All right, I just want to remind you how the answer is supposed to look. All right, so the equation of the circle is x minus h squared plus y minus k squared equal r squared, correct? All right, now what's h here? Nope. -2. What's k? 6. All right, and this is your radius. Okay, so when I write it, I'm going to say x minus h. What's h? -2. What do I do to that? Squared. Plus y minus k. What's k? 6 squared equal r. What's r? And I got to square that, right? Now, don't leave the answer like this. You need to rewrite this. You leave it like this, you're not going to get full credit. So don't say x minus -2, because you know x subtracting -2 really is what? X plus 2 squared. Now this you leave as y minus 6. And don't leave it like this either. The square root of 20 times itself is just what? 20. So on the worksheet, I think one of them, one coordinate's negative and the other one's positive. Just be aware of how it's supposed to look. Okay. All right. So that is in your final. They are going to have one like this in your final. All right, and that's going to be worksheet. This was worksheet 2.8 part 4. So that's due Tuesday. Or you could turn it in Thursday, actually. So go. Well, okay. You're probably going to want to study for your test. So go and turn it in Tuesday. Yes, turn it in Tuesday. If you want to do it for Thursday, that's fine. Yes.
Are we going to have like a review day?
No.
No review day, huh?
No.
You're gonna be learning new stuff?
Yeah. We're a little behind. So what we do Tuesdays is on it. All right, it's not gonna be that bad though. You'll be fine.
You sure?
But there is no review. The best. I always give you a study guide. That is your review. Take the time at home and look at the study guide. All right. Okay. So that's. Anyway.
So we have the test on Thursday and then the final, or is there a test and then another test and then the final?
No, test 3 and then your finals the following Thursday.
Okay.
Yeah. What? All right. Now, so that took care of this for your final. So you know one problem in your final already. Don't screw this one up. You know what it looks like. Okay. All right. You all should get an A on the final. I give you everything you need. Okay, now let's look at this. So on your test 3, test 3. On test 3, let's see if you remember how to do this. Write the following. So write the following. Let's see. Okay, so write the following. Let's change it. Use the properties of logarithms. Sorry, it's all right. You'll live. Use the 10 years from now, you won't even remember what I just did. Use properties of logarithms to expand the following. As much as possible. Okay. All right. Number 1. All right, suppose you had log base 6 of x cubed y to the 5th. All right, remember how to do that?
Yeah.
All right. What rule are you going to use? Or what property are you going to use?
Power rule and
The division.
No, not division. You're not dividing. What do you do to those two things? Multiply.
Okay.
All right, so the power rule and product rule. Which one are you going to use first?
Product.
No, product, not power, because the only time you use a power rule first is if all of this is being raised to a power. See,
Okay.
the only thing being raised to the third power is x. So you can't put that in front just yet because of this 5. All right, so you got to use the product rule first. Now, according to the product rule, what's going to be your next step?
Log 6.
Log base 6
Log base 6
of
x to the third plus log base 6 of y to the fifth.
okay. So log base 6 of x cubed plus log base 6 of y to the 5th. All right. Now I can use what?
Your power.
The power rule. So what's the answer?
3 log.
So remember, yes. So the power rule says you just take that exponent, rise the product. Take that exponent, rise the product. So 3 log base 6 of x plus 5 log base 6 of y. Okay. Okay, that's a 5th root of x. Okay.
Go back on her step 2.
What about step 2?
No, like, yeah, that one right in the middle.
What about it?
The one right under it. You
The-
said 3 log base 6 of x
Yes? Right.
plus 5 log, okay, I got it.
Yeah.
Never mind.
Okay. All right, what are you going to use here first?
The quotient.
Quotient rule. So according to the quotient rule, this is going to be rewritten as what?
Log base 3 minus
The 5th
the fifth
root of x minus
log base 3
of 9. Now you're going to have to rewrite the 5th root of x. So the 5th root of x, remember, is what?
1
X to the 1/5. X to the 1/5. All right, so I'm going to go ahead and rewrite this as x to the 1/5. So that's log base 3 of x to the 1/5 minus log base 3 of 9. Okay, so what can I do to this first one? So I'm using the power rule, right? So that's going to be 1/5 times the log base 3 of x.
You can solve the second one.
That's right. So without using the calculator, you can tell me what the log of 9 base 3 is. 2, because 3 squared is what? 9. And there's your answer. All right. And then what if you were, let's see. Let's say you had this one. The natural log. Remember, natural log has what base?
E.
E. And remember, the natural log of E is equal to what?
1.
Very good. All right, natural log of E is equal to 1. So what if you had the natural log of the square root of E divided by y cubed? Now, no, I wouldn't do that first now. What you use a power rule first because this quotient is being raised to a power. So do the power first. So that's 3 natural log of the square root of E. Oops, sorry. No, you're right. You're right. Thank you. Over y, right? Yep. So you do that first. Thank you. So you do the power first. Now you're going to do what? The difference. You're going to write the quotient rule now. So that's where you subtract these. But be careful. Remember how we said this? It's 3 times all of this, right?
Right.
So you're going to say 3 natural log of the square root of E minus what? 3 natural log of y, correct?
Yes.
Okay. No. What else can you do with the square root of E?
E. 1.
No, be careful, be careful. The natural log of E is 1.
1/2.
Yeah, what you want to do is, remember, the natural log of E is 1. That's not the natural log of E here. That's the natural log of the square root of E. All right, but you got to remember, you got to rewrite the square root of E as E to the 1/2. Okay, so now look what happens. So remember, the direction says simplify as much as possible. So you have 3 natural log of E to what power?
1/2.
1/2 minus 3 natural log of y, correct?
That's right.
Now, what else can I do to this 1/2 now?
Oh, you can move the power.
The power rule. So what's 1/2 times 3?
1.5.
But leave it as a fraction.
1/3
No, not 1/3.
Oh,
1/2 times 3.
is 3/2.
3/2. 3/2. Times the natural log of e minus 3 natural log of y.
Okay.
Am I done?
No.
Nope.
No, why?
Come on now. You need to know why. Why?
Because you couldn't reduce natural log.
I can rewrite the natural log of e as just
1.
1. So this 1 right here times this 3/2 is just what? 3/2. So 3/2 minus 3 natural log of y. There's your answer. Okay? All right. So notice all these little things that you have to deal with. Okay, and now,
This on the upcoming test?
yeah. All right.
Can't study it.
Now,
Thursday.
let's see. Now, remember I gave you this last time, worksheets 4.3 part 2,
Yeah.
and then 4.3 part 1.
I couldn't find those online.
Oh, I just posted them today. I gave them to you.
I know I didn't.
Yeah, so I just posted them today. But they're on there now. But I have the stack up there. If you just walked in, you didn't get anything from the table, make sure you get all those things you need.
I've got a question about one of those. I
Yes?
don't know that we've done one like, 4.2 part 2, under number 2C.
2C. 4.
4.2 part 2.
I don't have 4.2.
I was gonna show you.
Yeah, because that's the one I was.
She said this one, C.
It's got 10 and then log.
We did that. This a base where you have the LOG in the exponent?
Yeah, I don't remember. I'll look
Yes,
at
we
my
did.
notes. I didn't see something like that.
Yes, we did. Log of 7, 7 raised to the log base 7 of 400. We talked about that.
That's not how this one works.
It doesn't matter.
Okay.
It's the same base. If there's no base there, what's it understood to be?
Same argument.
10. So what's this thing equal to?
400.
400. And remember in the notes, in one of the notes, we explained why this was 400? We went back to a previous page.
Hold on. You posted
Okay.
a video that day?
Yeah, I think it was on, let me look, it's on, let's see. Remember this right here? This is the explanation that we used. We used this explanation. Remember all this?
Yeah.
That's it. Okay? That's what we used. Okay, this right here. So that was the explanation as to why, if the base is the same, the answer is just the argument. So that was what we did. Okay?
The base of log.
So you can't really see this when it's written down. So you really need to look at the words from the video. So that's on page 7. Okay. All right. So let's look at this now. Okay. So now we're going to condense. So what we did here was we expanded, right? So we went from a single logarithm to several logarithms. So we expanded. Now what's going to happen is you're going to be given this that I'm pointing to, and you're going to condense into one logarithm. Okay? So you're going to go from 2 or more logarithms, and you're going to condense it. Okay, now the properties are the same that you used before. They're the same properties. So remember, your properties are basically this. So if I have the log base b of m plus the log base b of n as a single logarithm, what do you think that is? Or what property or what rule do you think you're going to use here? The product rule. So this would be the log base b of what? mn. Now, that's only true if the bases are the same. They have to be the same. So then we also learned about this. What if you had the log base b of m minus the log base b of n?
Quotient rule?
The quotient rule, so you're going to write this as a log base b of what? M divided by n. All right. And then you learn that the log base b of m to the n power is just what?
Quotient power.
So it'll be n log base b of m. Okay? All right. Okay, so the way it's going to look is that you're going to be given this and you're going to go backwards. So you can be given this and you're going to go backwards like this.
And that's the power rule?
Yeah, that was a power rule. Okay, so let's look at this. All right, so let's suppose we had, so the direction is going to say use properties of logarithms. Remember, this is all section 4.3. All this is section 4.3. So we started 4.3 last time. We're still working on 4.3. So use properties of logarithms to condense each of the following. All right, so use properties of logarithms to condense each of the following.
Are you gonna by chance on the test give us the product, quotient, and power rules?
Yes.
You're insane.
All right. What if you had this one? So number one, what if you had the log of 5 plus the log of 2? Log of 5 plus the log of 2. No, that's not difference. That's a product. So I can write a single logarithm. So that's going to be the log of what?
5/2.
No, not 5 over 2. That's 5 times 2, which is what? 10. Okay, that's log of 10. Now, yes, so the directions will say, okay, use properties of logarithms to condense either the following. Where possible, evaluate logarithms without using a calculator.
How do you manage that on tests? Like take our calculators and show just point and give them back to us?
Oh, yeah.
Wait, what now?
How do you manage that on a test?
Manage what?
To tell us not to use our calculators.
Yeah.
Oh, I can't. I mean, you would just need to know that the log of 10 is 1. What's going to get some of you is probably one of them could say the log of 15. Then you're going to use your calculator and give me a decimal approximation, and then you're going to be upset with me and take points away from you because you used a calculator. You weren't supposed to use a calculator with a log of 15, right? Because it didn't say to approximate anything, did it? It does not say anything about approximation. So if this was the log of, if this was log 5 plus log 3, what would the answer be? Log 15. You're done. You can't do anything else to that. So don't take the calculator to approximate this, because nowhere in this problem does it say use your calculator to approximate. Okay? You do it, you're going to not be happy because you won't get full credit. And you're going to say, well, I had the answer, and said, yeah, but you didn't follow directions. Okay? All right. Now, so where possible, evaluate logarithms without using a calculator. So here you're supposed to recognize that if there's no base, it's understood to be 10, right? So that's a common logarithm. Common logarithm has what base? 10. Natural logarithm has what base? E. So you'd say 10, remember logarithm is an exponent. So 10 to what exponent is 10? 1. So that's 1. Okay, so that's the answer you would give. You would give 1. And you can always check yourself on your On your calculator, as she said, I'm not going to police that. I mean, you'll be using your calculator all over the place. So on your calculator, you just say log of 10. Make sure you do get what? 1. Okay? But you're supposed to recognize that don't leave your answer like this. Because you need to know that log of 10 is actually what? 1. The log of 100 is actually what? No. Log of 100 is actually 2. Log of 1,000 is what? You need to know that. 3. Okay. All right, number 2. All right, suppose you had the natural log of x plus the natural log of 7. What's the answer? 7x. Now make sure you put that in parentheses, though. Natural log of 7x. Because if you don't put in parentheses, here's what it means. So listen carefully. If you said natural log of 7x like this, then what you're really saying is you're taking the natural log of 7, and whatever that is, you're multiplying by x. So you got to put this product in parentheses. So this right here, they don't mean the same thing. Not the same thing. All right. 3. Suppose you had the natural log of 2. I'm sorry, the log of 2. Log base 2 of 96. Subtract log base 2 of 3. And then what's 96 divided by 3? 96 divided by 3 is what? 32? Do you remember what the log of 32 base 2 is? 2 to what power is 32?
4, 6, 4 is not
2 to the 4th power is 16. 5. So the answer is 5. Okay. All right, number 4. All right, number 4, suppose you had, let's say you had this. Number 4. All right, let's say you had log of 2x plus 5, like this, minus the log of x. Okay? What do you think the answer is?
Power.
Hmm?
It's gonna be the quotient rule still. So log 2x plus 5 over x. Is that right?
So the log, like this, right? Okay, so in parentheses, you're going to have your numerator is going to be what? 2x plus 5, and the denominator will be x, yes. Now, don't make the mistake of dividing out these x's. You can't do that because of that 5, all right? Okay, so just leave it like this fraction. Okay, number 5. Number 5, suppose you had, okay, now listen carefully. Suppose you had the log of x plus 3 log of y. Log of x plus 3 log of y. So listen to what I'm about to tell you. So when we did these right here, 1 and 2 and 3, for example. Let's do 1 and 2 for right now. Now remember, the property says the log of m base b plus the log of n base b is that single logarithm, the logarithm product, right? Okay. What is the coefficient here that I'm pointing to? 1. This coefficient is 1. This coefficient is 1. Subtract 1. And this coefficient is 1 as well, right? Okay. So when using the product or the quotient, these coefficients have to be 1. Here, when you look at this, I cannot use the product rule right away. Why can't I go directly to the product rule? Because the coefficient here is not 1. So I have to use what rule first? The power rule. So you got to use the power rule first. In order to use those properties, those coefficients have to be 1s. So use power rule first. So this is going to be log of x plus what? Log of y cubed, just like this, right? Now I can do what? Product rule. So it'll be the log in parentheses. What are you going to write? x, y cubed. There's your answer. All right. So you wrote it as a single logarithm, and the coefficient in front of the log is 1. Okay.
I don't think I understand that
Huh?
one. I don't think I got that one.
What didn't you get? You told me a while ago the power rule. So what was the issue going from here to here?
Undo it, and then.
Undo it?
No, I think she just had to.
Oh, I see.
Undo it.
Like going backwards. So that's the log of a product. So you write as a sum, and then you rewrite this. You get
Only
that.
on the Y and not outside of the parentheses.
Yes.
All
Right.
right, thank you. That actually makes a lot of
It's
sense.
undo it, it's obvious.
Okay. 6. Suppose you had this. 5 log base b of x plus 6 log base b of y. What's the answer? Well, first of all, what are you going to do first? Power rule first. So you're going to take this, write as a power. Take this, write as a power. So this becomes log base b of what? X to the 5th plus log base b of y to the 6th. And one more step and you're done. What's the answer? What rule? Product. So what I'm going to write? Yeah, remember it's a product, right? X to the 5th times y to the 6th. So that's your answer. So you wrote it as a single logarithm, and what's this coefficient out in front?
And this is on the test Thursday?
No, that's in your final.
Oh, this is on final.
Yes.
I could deal with it.
Um,
No worries.
okay, what if you had this? This is number 7. And that's all this really is, just rewriting it as one logarithm. All right, you had 8 natural log of x plus 9 minus 4 natural log of x. It's just using your properties. So can I use a quotient rule right away? No. So you want to condense this. You want to write as one single logarithm. But before you can use a quotient rule, these numbers here, the coefficients here, have to be what?
The same.
No.
You have to put on one.
The coefficient. I didn't say bases. I said coefficients. The bases have to be the same. They are. They're both base C, right?
Yeah.
But the coefficients have to be what?
This is one.
Ones. They have to be ones. So you have to use the power rule first. So you can take this coefficient and write it as a power, as an exponent. You can take this coefficient, write it as an exponent. So when you rewrite the 8, you're going to say the natural log of what? X plus 9 to the 8th. That's how it looks. Minus the natural log of what? X to the 4th. And then one more step and you're done. So what rule are you going to use next?
Quotient.
Quotient. You're subtracting, use quotient.
So, natural.
You gonna do natural open?
X plus 9.
In parentheses, the x plus 9 to the 8th, and then
And the L
x to the
4.
4th. And there's your answer. Okay, and then you can always go backwards and kind of check yourself based on what you learned last week. So you would use the quotient first. So you'd say the natural log of this minus this, right? That's what this is. And then you would take the exponent, put out in front, and that's what this is. So you can always think about yourself going backwards with this and see if it makes sense. But in order to do all this, you're just using 3 properties: power rule, quotient rule, and product rule. That's all you're using. Okay? All right, now, let's look at this for a moment. What if, I can hear that now. Okay, what if you had this? Look at this. So let's say you had now remember on your test Thursday, there's 4 problems. They're 1 point each. So 4 of however many points it is this. You're not going to maybe use your calculator on. So one of them would be something like you telling me that the natural log of e to the 7th power is what?
7.
7. The answer is 7. That's what you would have to tell me. All right, so you can do this without a calculator because you remember you can use so in your mind, that's what you're thinking. So I can use a power rule, right?
Right.
Okay, so that becomes 7 natural log of e, and then that's just what? 1. And 7 times 1 is 7. Okay. So something like this, you're going to have to, there are 4 of them, you would have to be able to do without a calculator.
Give us one more example. One more example.
Let me come back to it.
Okay.
Okay, those are not difficult, you can do them. But I want to get to this one though. What if you had this? What if you had this? The log base 3 of 27. Can you do that one?
Yeah.
Yes, you can, right? You can do that one. What's the answer? 3. So that would be another one you would have to do Thursday without a calculator because you're saying 3 to what power is 27? 3 to the third. Y'all agree?
Yes.
Okay. So remember we did the box. We said so on your test it'll say this. What you may want to do. So remember it's going to look like this. That's all it's going to say. What you may want to do is put a box here, and then change this log equation to an exponential. Remember that? So how do you change this to an exponential? 3 to the box equal 27. That's what we did last week or the week before when we started this. So the box is what you would probably want to write yourself. And then you would think, well, I know that 3 to the second power is 9, and I know that 3 to the third power is what? 27. So the answer is 3. But what you had this, what if you had the log of 17 base 3? Log of 17 base 3. Can you tell me what that is? So you can't tell me right away what 3 to what power 17, right? Because there's no whole numbers. See, these were whole numbers, right?
Right.
So it's really a decimal that this equals. It's an irrational number. So 3 to what power 17? You got to figure that out. You have to use your calculator on that one. So you see the base is 3, right?
Yeah.
On your calculator, we talked about this. On your calculator, what bases does your calculator use in terms of logarithms? 10 or e. 10 or e. Your calculator uses base 10 or e. So given this, you can use your calculator to approximate what this is. All right, so there's something called the base change formula. The base change formula. And I'll give you the base change formula. You just need to know how to use it. The base change formula.
Is this 4.4 now?
No, that's still 4.3. It's still 4.3. All this is 4.3. So base change formula says this. If I have the log of m with some base b, I can change that expression to any base I want to, as long as the base is positive, and it cannot be what positive number? 1. So I can change this base to whatever base I want to. So there's an infinite number of bases this can be. So I can change it to a new base, and this is what it would look like. It would be a fraction, so you'd have to rewrite this as a fraction. You would say the log of m first. That goes in the numerator with my new base, and let's call the new base a. So the log of m base a. So I want my base to be a, okay? So it's going to be the log of the argument with my new base divided by the log of the old base. And what's the old base? B with my new base. So just look how it looks. So what's my new base? A. So notice my new base is A. The argument here is this one. And the argument here is the what? The old base. Okay? So look how it looks. What? I'm just dividing what now? What'd you say? Okay, I'm not sure if you're talking about this or this. That? What about this one? Tell me what you asked me. Okay. All right. So let's suppose we had this right here. The log of 17 base 3. Let's suppose someone wanted to rewrite it base 4. Okay? It's not going to help you in a calculator, right? But could someone have used base 4?
Yeah.
Yes. You could change this to whatever base you want to. So if someone wanted to use base 4, you would say the log of 17 base 3 is equal to a fraction. You would have the log base 4, and what's going to be the argument here? 17 divided by the log base 4 of what? 3. That's what it would be. If someone wanted to use base 5, they could have. They would have said the log base 5 of what? 17 divided by the log base 5 of what? 3. If someone wants to use base 2.6, you can use decimals. 2.6, you would say the log base 2.6 of what? 17 divided by the log 2.6 of 3, and so on. How many of these are there? An infinite number. But if I'm going to use a calculator, then I want to use what base? 10 or E. Okay, so what you're going to do is you would say the log base 3 of 17 equals, now let's use base 10. Now remember, base 10 is the common logarithm, right? Okay, so we say the log of, what's my argument? No. 17 divided by the log of what? 3. Now, don't write the base 10 because remember, LOG is understood to have what base? 10. All right. So I know I wrote the bases here because you have to write the bases if it's something other than 10.
I think you just confused everybody with all that.
What now?
You confused people with that.
With what?
Like the log of 4, the log of 5.
Well, no, the whole point is that you need to know that there's an infinite number of ways to write the base. But if you're going to use a calculator, you need to use what base? 10 or E. Okay? All right. Now, on your calculator, let's see what this is. Log of 17 divided by the log of 3.
2.58.
Yeah, now, in the directions, it will probably say 4 decimal places.
2.5.
So 4 decimal places. Now, when using your calculator, you're going to say the log of 17, LOG, 17, close the parentheses, right? Then say divide by the log of 3, close the parentheses, and press equal. So 2.5789. So 2.5789. Okay? Now that means that all of these were also going to equal what? 2.5789. All of these that had the different bases was also going to be 2.5789.
So we do it with E, we'll get the same.
Yep. So if you want to do this, you would say the natural log of what? 17 divided by the natural log of what? 3. Okay, use natural log now. Natural log of 17. Close the parentheses, divided by natural log of 3. Close the parentheses, equal, and notice you get the same thing. 2.5789.
Why is that?
Well, so if you go here, we had the log of 17 divided by log of 3. And remember, that was a log of 17 base 3, right? Okay, so let's go ahead and use this one. I'm going to go ahead and use the other one that we had here. Okay, so if I go back and change this to base B, I'm trying to get this back. If I go back and change this to base B, that would be the log. It's going to make this difficult. Log of base B of M divided by the log base B of A, right? That's this right here. Divided by, and this would be the log base B of B divided by the log base B of A. Now you have this complex fraction, so you have to rewrite it as a multiplication problem. So you have log base B of M divided by log base B of A times the reciprocal of this, log base b of a divided by the log base b of b. Now these two are the same right here. They divide out. This log base b of b is just what number? 1. And all you're left with is what? That right here. All right, so if you do all of this with this, now those of you got this complex fraction you have to rewrite, you'll get this back. So all of this, you rewrite it using this base 3. All this will end up being this back. Okay? So anyway, so that's how you can always go backwards if you want to with this. Okay, and then one more. So it's just using the formula. One more would be, let's say, log 2.6 of 7.3. All right, so what are you going to do? Use your calculator. What are you going to write it as?
Log 7.3
Divided by?
log of 2.6
Yep. Or you could have said natural log, right?
or natural log.
It did not matter. Did not matter. All right, so log of 7.3 divided by log of 2.6, you get 2.0804.
You get the same thing with natural log.
Huh?
You get the same
You get right. You get the same thing if you had used the natural log. So both of those are the same thing. Okay, so that's the base change formula. So on that worksheet, on the worksheet 4.3 part 3, 4.2 part 3, you should be able to do all this now. So this was multiple choice, so pick the correct answer. And then here it says use properties of logarithms to condense. So just put the answer here. And notice that if possible, evaluate without using a calculator. So letter A, you'll be able to do that, and letter C. So letter A and letter C, you can go further without using a calculator. All right, so I made sure that all the bases are the same. They should have been the same. That's 4, and everything else is base 10 or base E. And then here, that's the base change formula. Okay? Base change formula. All right, 4 decimal places. So that was the end of 4.3. That was the end. Okay, now we're going to look at log equations and exponential equations. So this is where we headed in 4.4. So there's usually 2 questions from 4.4 in the final. So here's where we headed. Listen carefully. So there's usually an exponential equation and there's usually a log equation, and that's all section 4.4. So section 4.4 is where they start talking about exponential equations and log equations. All right. So you'll be able to you're going to be solving things like this. So solve each of the following. All right, so something like this. So let's say you had 3 to the x plus 1 equal 9 to the x power. Let's say we had that. All right, now we're not going to do it right now. I'm just telling you where we're headed. Now notice this is called an exponential equation. Why is this called an exponential equation? Okay, equation because of the equal sign. I'll give you that. Why is it called exponential?
Because there's a
Variable in the exponent. So that's why it's called an exponential equation. So the variable, remember, an exponential function is a variable is located in the exponent. This is an equation because of the equal sign. All right, then you can be able to do something like this. Suppose you had 4 to the x power equal 3 to the 2x minus 1. All right, you'll be able to do something like this. This is also called an exponential equation. Then you're going to have this. the log of x plus 3 base 2 equal 6. You'll be able to solve that log equation. This is a log equation. Equation because of the equal sign, log equation because you see the word log. Then you'll be able to solve something like this, and I'm making these things up. Log base 2 of x minus 1 plus log base 2 of x equal 6. Okay? All right. I know you don't want to do it, but hey, you want those 8 points. You want those 8 points. That's why you want to do it. All right. Now some of you are going into business calculus or calculus, so they do have logarithms in that course. Business calculus or calculus. Now some of you, this is probably your last math. Okay. All right. Now, so these are the couple of those are fairly easy to do. A couple of those is quite a bit of work, but it involves your calculator. A couple of those. So let's go ahead and take 5. Now remember, take 5, right? Some of you don't know how to use your watch. Take 5. Take 5. It's almost over. 1 week left.
2 more classes after.